Okay, so 4.2 is all about determining whether the solution or the ordered pair. Okay, so 4.2 is all about determining if a given ordered pair is actually a solution to the equation given. But let's first start about reminding ourselves how to solve. So I want you to take a moment and solve this equation, okay? So hopefully you got m is equal to -2. So this number, this -2, that's a solution, okay? And remember, a solution is the number that makes the equation true. One variable means we need one number. However, if we have two variables, such as this example down here, we're going to have two numbers as the answer. Okay? So again, remember the solution is the number or numbers that make the equation true. Okay? Two variables means two numbers. Two numbers means that it becomes an ordered pair and that there's many solutions, okay? Because it makes a line, and there's not just one dot or one ordered pair. The line is the whole thing, okay? And lines go on forever and ever and ever, so there's an infinite amount of solutions. Okay, so you may be thinking, all right, well, let's do this then. How can we figure this out? So we have to remind ourselves, what's an ordered pair? An ordered pair, remember, is x, comma, y. Okay. Okay, so now you're wondering, okay, now that I know what an ordered pair is, what does that mean? So I'm going to look at this ordered pair down here on A, and I'm just going to first label which is my x and which is my y. So this 3 is my x, and this 11 is my y. So now that I've labeled them, how we determine whether it's a solution is by plugging these values in for x and y. So wherever I see x, I'm going to plug in my x value. Wherever I see y, I'm going to plug that in. Okay, so I first always start off by rewriting the problem, and then I write what I plugged in. So 11 is equal to y. So I write 11 equals 4. And then x is equal to 3. So times 3 minus 1. Okay, and remember, a solution, it's an ordered pair is only a solution if it makes the equation true. So we have to figure out, is this actually true? Well, let's first do 4 times 3 is 12. 12 minus 1 equals 11 is what we'd write. And then 12 minus 1 is 11, and it's equal to 11. So is that true? Is 11 equal to 11? Yes. Okay, so then I check off that that's true. And is this ordered pair a solution? Yes, it is a solution. Okay, so again, let's look at B. We first determine which is x and which is y. So this is x, this is y. I always start off by rewriting what I'm plugging it into, just so I know. Okay, and then I plug those values in. Y is 3, so now I have 3 equals 4. X is 10, so 4 times 10 minus 1. And then I evaluate. 4 times 10 is 40. Is 40 minus 1 equal to 3? No, because 3 is not equal to 39. So I draw a line through. They're not equal. And since they're not equal, then it's not a solution. Okay, I want you to try letter C for me. Just take a moment. Okay, so again, the first thing you need to do is identify which is your x and which is your y. Okay, then once you do that, you plug it into the given equation. So, and then at some point I had 41 minus 1 equals 43, which gave me 43 equals 3, which is true. All right, let's look on the next page. All right, determine whether each ordered pair is a solution of that. Remember, we have to make sure that we solve for y first, just like from 4.1. Y has to be alone, okay, in order to determine anything. So let's first start by solving for y. Okay, so I'm going to draw my river. I'm going to add x to both sides. Okay, so after we add x to both sides, we get 7y equals x minus 8. And then we still need to get that x alone, so we divide both sides by 7. And we, again, always want x to be either written as a whole number or a specific fraction on its own. So we want to write it as a fraction such as 1/7 x and then minus 8/7. Okay, so that's going to be my equation. So my equation is y equals 1/7 x minus 8/7. So really not the cutest equation to try to plug things in for. So you'll have to really rely on your calculator. All right, so now that we've solved for y first, we can check that off the list. Now we need to determine whether each ordered pair is a solution, okay? So let's do that. So let's do the first one. Remember, an ordered pair is x and y. So we're going to plug these values in for x and y. So y is equal to -1. So -1 equals 1/7 times 1 minus 8/7. Okay, so I'm going to do some math here. 1/7 times 1 is 1/7. And I do 1/7 minus 8/7. Remember, when you're adding or subtracting fractions, as long as they have common denominators, you subtract the numerators. So I get -7/7 is equal to -1, which I know 7/7 is 1 and it's negative. So is this equation true? Or is the solution true? Yes, it is a solution. Okay. One more. Let's look at B. Okay. So try B on your own. Okay. So a calculator would have been really helpful. Okay. So you plugged in -3 for y and -7. And eventually you should have gotten that 3 is not equal to -2 1/7 at the end here. So if you just plugged all of this in your calculator, that's fine too. But you should be able to do that without a calculator. So I want to point out something else down here. Well, before I do that, your homework is letter C. Okay, so do that for me. So let's look at this graph real quick. So A was the ordered pair 1, -1. And B was -7, -3. So I have this graph down here with this line. So this line is graphed below. So I can take these ordered pairs and see if they are on my graph. Okay, so I'm going to 1, -1, which means I go over to x and down -1. So there's A. Is A on my line? Yes, right? So that's why it's a solution, because it's on the line. What about -1, 2, 3, 4, 5, 6, 7? Wait. 5, 6, -7, -3. Is that on my line, this point? No, my line's 1 up, so that's why this is not a point. Okay? So once you get your answer for C, I might check it on the graph to just make sure I'm right.